Welcome to the lecture series on vitamins and nutrition. So, in the previous session, we were looking at the variety of food substances which are enriched with vitamins. We also saw the role of evaluating different ingredients in the food substances. Now, in this session, as a continuation of the previous session, we are going to look into different methods of evaluating the nutritional status of individuals. So, this is extremely essential because until we do this evaluation, we will not be in a position to recommend the essential supplement what would be required for a person. Now, when we look at it, when we do the nutritional status evaluation, we do a nutritional status evaluation of macronutrients as well micronutrients. Now, when you look at this, the micronutrients, basically the vitamins, also plays a very important role in evaluating. So, the macronutrients are much easy to identify, whereas looking into the fine requirement of micronutrients, especially vitamins, is always challenging. So, in the previous session, I was explaining about the biochemical methods of evaluating the nutritional status, and in this session we are going to continue from that part where we can use immunocompetence tests to evaluate the nutritional requirement of an individual. So, if you look at over here, the immune system basically responds to the nutritional supplement we provide. So, what we do over here in this immunocompetence, we try to look into different kinds of immune cell profile. The simplest one, you just check the amount of lymphocytes, the amount of dendritic cells, the amount of macrophages, and the variety of immune cell status, and a simple blood count to look for the immune cells would give you a clear indication of the nutritional status. But suppose if you say some of the essential B vitamins, for example folic acid and vitamin B12, vitamin C, any depletion in them would directly affect the immune response. In fact, if you look at it, one of the reasons why people often fall sick is because they may not have taken sufficient amount of vitamins required to protect their system. So, that way immunocompetence is one of the important tests to ascertain the nutritional status of an individual. Now, we do also have one more test, what we call it like anthropometric measurements. So, what is this anthropometric measurements? So, what we do over here, we look into the morphological measurements. So, you see, you measure the size of muscle, you measure the size of bone, the amount of adipose tissues, and this will give you an estimate of whether nutrients are really being utilized by the individual, or in the first place whether nutrients are really available for the individual for normal metabolism. Because the person might be taking protein rich diet, but if it is not taken with the required vitamins, muscle development would be affected. Same is the case with bones. Suppose if a person might be taking very good amount of calcium, but you might find the bones are still weak. The reason is they may not have taken vitamin D, and vitamin D is essential in the utilization of calcium. So, this goes hand in hand. So, that is what we mean by anthropometric measurements. So, if you come across and if you find any deficiency or variation, and if you could directly connect this with the dietary intake of vitamins, we would be able to ascertain what particular vitamin that this individual lacks. So, you look over here in some of the parameters concerned with anthropometric measurements, you also find the height, weight, body mass index, the body circumference, the waist, hip and limb, and the skin fold thickness. Everything needs to be considered. So, if everything appears within the limits, then we say the person is been getting sufficient amount of essential vitamins for the normal metabolism. Even if you are going to lack even some of the few vitamins which are essential, this would definitely reflect on all the anthropometric measurements. leave alone the immunocompetence or biochemical. So you may ask a question, so which one I should go for, biochemical based methods or immunocompetence or anthropometric measurements? It's always good if it's going to be a kind of a research investigation, we recommend taking all three. But on a clinical note, even a biochemical test would really make sure to decide how much amount of vitamin supplement that needs to be given for this particular individual. In other words, dose determination for particular vitamins is really estimated only with the strong biochemical data. Now you may ask a question, whether we can give an empiric therapy of vitamins. That's what in most cases people do. Most of the clinicians, if they already have an underlying disease or if they already suspect symptoms of one deficiency, let us say the most common one being anemia, a paleness or shortness of breath, and immediately they start them with an empiric therapy of I would say folic acid or vitamin B12 and iron supplements. So it can also be done that way. But if it's going to be a research investigation, a systematic evaluation in all three levels are required, and that will help us to really understand the role of particular vitamin and whether this vitamin is really able to restore the deficiency being faced by that particular individual. In fact, historically, if you go back to this particular slide, Howard conducted one experiment. In fact, that's one of the classical experiments where a group of patients were being fed on a diet which was deficit in vitamin A, and for a period of 2 years. So Howard was able to closely monitor the progress of these patients, the way in which they showed symptoms, and that was one of the first of its kind, because nowadays we won't allow patients to undergo a nutritive depletion based diet on a clinical trial to evaluate any vitamin, but Howard's time it was allowed, and that's one of the experiment that people always look into. So what they did was they were able to look at what would be the disease profile or the pattern of disease, the metabolic changes that happen when a person is on a deficit amount of vitamin A. Normally in the world we find when people take any food which lacks vitamin A, they definitely show symptoms of night blindness. But in this study, Howard did a very systematic way of evaluating the dose based disease prevalence, and that's one of the reason you look over here that he used all three tests to really understand what all the pathophysiological changes accompanied by vitamin A deficiency. Okay. So now we are going to look at the this is a table. This particular table tells you what all different kinds of tests that we need to do to really understand the amount of vitamins present in a particular individual. So if you start from vitamin A, so we can do a direct serum vitamin A evaluation. Then if you go to vitamin D, so you look for certain enzymes and their role and their presence. So in this at the other end of the table you find the adult estimated value or the accepted reference range, and in the middle one the test names are mentioned. So this kind of tests are basically simple biochemical tests. In case with serum evaluation of vitamin A, we do spectrophotometric analysis of vitamin A, which is being a colored substance. We would be able to measure the quantity of vitamin A present in the system. So all these tests are basically trying to understand and quantify the list of these vitamins present in the body fluid. It could be in the systemic circulation of blood, or it could be in any of the body fluid that we are trying to evaluate, and this list gives you the range. So this is the middle one gives you the test. See, for example, in case with vitamin C and vitamin E, vitamin K, you look at all these tests, there is a close resemblance because most of them are fat soluble except vitamin C. You are able to really look into their presence by directly evaluating their presence as a plasma component. Now in the B vitamin evaluation, you find here there is an interesting thing. Erythrocyte transketobase enzyme is used for stimulation, and the urinary thiamine excretion is evaluated. The point we need to notice over here, in all these studies you always find for water soluble vitamins we directly take the analyte. In most cases the analyte happens to be the urine source, where the water soluble vitamin would be eliminated, and if you could check the amount of these substances in the urine, that could be an indication of how much amount of vitamin has been excreted by the individual. If the quantity is very low, then that's a sure indication the intake or a natural depletion of this particular vitamin has occurred in the individual. So you also look here for folic acid, we look for serum folic acid level, we also look for erythrocyte folic acid level, because serum folic acid level and erythrocyte folic acid level is a direct indication of the health of the individual cells. So look over here in riboflavin, you again look for erythrocyte glutathione reductase. So these are some of the enzymes which actually play a very good metabolic role in close association with the corresponding enzyme and corresponding vitamin. So if you could use these tests, it's a direct indication of the presence of these vitamins in the body fluid, and here is the reference range. So it continues here. So in most of the tests, if you could carefully make an analysis, you find that either we look directly into the serum plasma or we are taking analyte from the urine. So most of the fat soluble, if you closely watch, most of them are being evaluated from the body fluids, whereas when you say about B complex vitamins, we are looking at their presence in the urine and certain excretory components of the body fluid, whereas most of the other enzymes which are fat soluble, you find them in the plasma. So you look at this one more table. So this is a table which gives you the preferred alternate assay methods for evaluating the presence of vitamins. So what are these methods? So in the previous methods we directly saw the biochemical based evaluation of these vitamins in the system, whereas in this slide we see different methods. For example, we are using microbiological methods, we are using enzyme analysis, and we also use HPLC. So these are all modern methods. So what is exactly HPLC? HPLC is like high pressure liquid chromatography or high performance liquid chromatography. In this case we basically use mobile phase and a stationary phase, and the substance which are being used, the analyte, gets segregated based on the affinity for the mobile phase and the stationary phase. This exactly gives us the composition of the fluid that we are evaluating, and HPLC based methods are becoming very popular, and most of the pharmacopoeias, when they try to evaluate the vitamin present in the supplements, use HPLC based method for understanding the presence of a particular ingredient in circulation. So you look over here, you have the list of tests being mentioned, and then you have the other alternate methods being mentioned over here. So you find over there the general spectrophotometric analysis, where you have the use of absorbance based techniques. The amount of vitamin, depending on the concentration, they are able to evaluate how much amount of substance would be there. See, for example, each vitamin has this ability of absorbance of a particular wavelength of light, so which is directly connected with the concentration of the particular substance present in the body fluid based on the Beer-Lambert's law. So that particular principle is applied over there, and if the vitamin happens to be a colored vitamin, okay, like let's say A, or if you have riboflavin, and they tend to show characteristic absorption, and that's what it's been evaluated in the spectrophotometric methods. Whereas if you look at other methods, for example, you find over here competitive protein binding assay. So, what is this competitive protein binding assay? Being used for vitamin B12 and being used for folic acid. So, competitive vitamin binding or a protein binding assay means, so there is a protein which acts like a kind of a carrier, and you add this particular vitamin from an external source, and the vitamins which are already present in circulation has to compete with the external source, and the one which we use it as an external source, if you are going to radio label them, then clearly we will know which one is replacing what. So, that way we are able to evaluate exactly what would be the role of these individual vitamins in providing the basis for understanding the quantity of that particular vitamin in the body fluid. So, you may ask, so why we have to do this? So, as I have told you earlier, only when we do this test we would be in a position to really understand how much amount of vitamins are there in the first place, and only based on that we would be able to recommend the required dietary supplement needed for that particular individual. But in any cases, it is the empiric based therapy which is being recommended by the clinicians, which are already there in practice. But in any case, when we are going to do a research investigation, we need to do a detailed evaluation. So, when you study the analytical methods, when you study the way how vitamins are required in body systems, quantification is extremely essential. Without doing any quantification assays, you won't be in a position to really understand or make a connection between the concentration of the vitamin and the kind of physiologic response you are expecting. So, we are going to look at one more set of table over here. So, this particular table compared to the previous table, so this previous table gives you a list of methods. It could be biochemical method, it could be microbiological method, it could be HPLC method. All these methods tell you the standard of particular data what you could obtain for a particular vitamin that you are trying to investigate. You want to know the profile of this particular vitamin when it is being taken for systemic circulation. Now, the second one, this slide actually gives you the indicators of the preferred vitamin assays in analysis. In other words, what we are trying to look over here, we are trying to look at different types of substances, vitamins which are present and evaluated by different methods. Like for example, we are using HPLC, we are using microbiological, and we are using competitive protein binding assay, and of all these we do a comparison. I mean, which one would really give you the kind of plot. So, there is a wide range of literature available, and depending on the availability of resources, each lab can select any of these methods or could use even multiple methods, although it might appear redundant, but that will really ascertain the kind of data that what we could really derive. So, immunological based methods of diagnosing vitamins are still underway. So, right now the spectroscopic methods are the ones which are extremely useful and popular compared to microbiological and other methods. So, with the recent technique of HPLC and other chromatographic methods which are picking up, the evaluation of vitamins are being used more effectively and in a more accurate way. So, now we are going to look into the formulation aspects of vitamins. So, now we have a clear picture of what we are going to measure that would help you to determine the nutritional status of an individual. After we do this, we try to evaluate individual vitamin in a particular person. So, the first one will give you the nutritional profile, then we supplement them with a particular vitamin, and then again we evaluate whether the vitamin what we supplement is able to like really bring about the physiological change what we are expecting. Now, in this section we are looking at various factors that are involved that is going to really affect the presence of vitamins in the food and formulations concerned. So what do you mean by that? It means you might be planning, let's say you want to add 2000 units of vitamin D, international units of vitamin D in your tablet, and the question would be, you have to do a measurement, that's what we have looked right now, then you incorporate them and you make a formulation. So when you make a formulation, what happens? You fortify the particular component with that extra bit of vitamin, taking into consideration that there would be bioavailability issues, at the same time issues connected with storage and so on. So now when we do that, we have to be aware of, when you make a formulation for vitamin, what all the factors that could really affect the productivity of that particular process, at the same time that could really affect the final formulation, that could really carry over the particular vitamin available. So if you look at these factors, it will be quite interesting. See here, you should now consider vitamin as an entity by its standard of physical and chemical properties. So when you are going to prepare a formulation for a vitamin, you would obviously add additives. Now the second point is what we mean by like premixes or finished feed varieties. So it means what? The active ingredient being the vitamin, and there would be other supplements added, and they create a kind of a premix. So in such cases, if we do not have a clear-cut methodology for evaluating, we would end up giving a dosage which may not prove to be beneficial, or on the other end it could end up in too much of a particular dose that can lead to toxicity, or it could also be a problem connected where you would have issues in really tracing back any kind of adverse effect that results from taking too much of vitamin. So you see over here, what are the factors that we need to consider when we prepare a vitamin product. So we have to look into the bioavailability issues. We have already seen that uniform vitamin activity, which is evaluated through a bioassay, then the optimal handling and mixing characteristics. For example, one particular vitamin should not stay in one particular corner of the preparation as you are formulating. It should be evenly distributed, and when it's coming from the hopper, suppose let's say you are making a tablet, vitamin tablet, the ingredient should mix well. So that's what we mean by high flowability, low dusting, low hygroscopicity and caking, and minimal segregation and carryover effects. So it's basically a very quick summary of what's exactly going on in the formulation, because formulation in itself a separate topic, and when you consider working on with vitamins as a supplements, the standards for formulation what we apply for tablet or any other formulation also holds good here, because this would give you an indication where you would be in a position to identify which ingredient might interfere with the property of the vitamin and which might likely affect the property of the vitamin. You have to take into consideration in what way the composition would enhance or at least not hinder the activity of the vitamin. Now when you look at this, here we have a picture. So this particular picture gives you the kind of balance that we need to consider. So the bioavailability parameter, the stability parameter, and the mixability parameter. So all these three should be in a kind of a fashion where that will not affect the actual requirement what we have for a particular vitamin in a formulation. So we have to look into the bioavailability as a primary criterion, and because after you make everything and if the vitamin is not available, it's not going to help us. At the same time, you have added, you have taken care of bioavailability, but what about stability? If the vitamin is going to get degraded, then again that's going to directly affect the bioavailability. And mixability is, after considering these two parameters, after doing pilot studies, we try to do one more set of studies to ensure all the additives used in the preparation are able to evenly get mixed, so that the final preparation will have all the essential vitamins what we are looking for incorporated in the formulation. Here we have a list of a food based profile. So this file might look little hard in the middle, but what I want to bring in over here, I am just giving you a profile. So when we are going to rely on a natural source, because in the previous slide I mentioned about how you synthetically formulate, taking the active ingredient from different sources. So this is one data where if you have a dairy source for vitamins, the source which is being used as a raw material, how that can directly affect the formulation. So you see there the vitamin content present in cow's milk, goat's milk, and then you have the ewe's milk, mare's milk, and also the last one sow. So this is basically, the last one is pig's milk. Anyway, we are not going to do that, but they have done a kind of a comparison to tell you which particular milk is more enriched with particular kind of vitamin, and the feed which has been given to these animals had a direct impact on the material, food material available. And now if you are going to use them as a raw material for basically using a organic concoction of vitamin, then we have to take into consideration all these parameters. But the problem in this kind of a system is that whenever we go for organic, it is always an issue how we standardize. So we can only standardize by providing a stable input of vitamins when we are after organic food. So we have to like tailor make the amount of vitamins and constantly check the output of the vitamins which get enriched in the organic food source that we are harvesting. But that's not the case for synthetic material. So it's much more flexible. So you see over there, when we make a formulation, the synthetic formulation, the previous one was something like you look into the overall profile of vitamins, how they get affected depending on the species that we use for raising the milk. Now the next example gives you the picture of variety of components that can affect the stability of vitamin products. So we might be thinking the vitamin is fortified, but you have to also take into consideration all these parameters: the temperature, the water content, the pH, the oxygen component, because that's going to have an oxidative effect on the preparation, then irradiation as a technique for sterilization, then catalysts present over there as component of additives, then inhibitors, then the kind of interaction they might have with your own body tissues, then the energy value that they are going to offer, and exactly when you say time is the overall time required for the formulation. So here we have, let's say this is an interesting table. So for each of the vitamin, which one is going to play a major role in affecting the stability of the vitamin. So we have a marking over here, slightly sensitive, the double X gives you very sensitive, and 0 refers to stable. If you look at over here at A, vitamin A, you see over there they are extremely sensitive to temperature, oxygen, humidity, light, and pH component is acid and an alkali. So they are stable at, I would say, alkaline conditions. So whereas if you go over there, let's say B vitamins, let's say nicotinic acid as a comparison, you see over there they are quite stable at a temperature with the humidity factors, almost they are like really fine. Whereas if you look at certain vitamins, if you look at folic acid, temperature plays a major role. And as you keep over here, this is a kind of a table that we need to constantly refer and incorporate these features when we do fortification process, and make sure the vitamins would remain stable. Not only the vitamins being formulated, even packaging and storage plays a major role in preserving the potency of the vitamin. So that's why the kind of packing chosen would create a barrier and prevent temperature, oxygen, humidity, and light being directly exposed to the vitamin, removing its stability. So we are going to wind up with a session. Now I am going to give you a quick recap of what we have been doing in this series of lectures, and especially for today's lecture. So I started with explaining what all the different factors that plays an important role in governing the analysis of vitamins. So we saw how each vitamin can be evaluated for its content in a nutritional status. So we evaluate their presence in the human physiology, and we also parallelly look for a comparison of which method would be more reliable in selecting a suitable way of checking up the presence of vitamins, both on a clinical note and both on an industrial note, in terms of evaluating the presence of vitamins in a formulation. And we also looked into different factors that we need to consider when we are formulating these vitamins, and how that is going to directly affect the stability of these vitamins. And the last bit was more into the formulation aspects of vitamin, the combination of bioavailability, stability and mixability, and we also looked into the comparison of the source what we are using that could have an impact on the final preparation. And we also looked into the parameters of various external features that's directly having an impact on vitamin stability. And last of it, we also looked into different fine parameters that we need to use or control when we are formulating these vitamins. Either we are going to prepare them as a multi-vitamin preparation or as individual preparations, how in every stage we need to consider them as an important feature in preserving the fidelity of the final formulation. I hope in the coming sessions we would try to add more of individual vitamins and their biochemical role and their individual impact on the human physiology would be dealt elaborately. Thank you.